Anything that has mass and occupies space is known as matter, and each and every matter is composed of minute particles known as constituent particles. That means, for example, pen, pencil, your body, my body, everything that you see around you is known as matter. And these constituent particles in a matter are held together by a force of attraction known as interparticle attraction. Now consider an ice cube, water taken in a beaker and a water vapor trapped in a container. As you know, three of them are exactly same thing but existing in three different forms. All the three contain H2O molecule but they are existing in different forms, and the reason why they are existing in different forms is that the interparticle attraction experienced in three of them is different. And as a result of this interparticle attraction, everything is existing in different form, and those different forms shown by matter is known as the three different physical states of matter, and they are solid, liquid as well as gas. Here as you can see, ice can be considered as a solid, water a liquid as well as water a gas. So without any doubt, the factor which decides different states of matter is the interparticle attraction experienced in between the constituent particle of every matter. Now, if you consider a mobile phone, as you see, this has almost a rectangle shape, and if I place this in my hand, it is occupying a definite space. So, the space occupied by every substance is known as its volume. That means any matter which has a definite shape and a definite volume can be considered as a solid. Now consider I have taken some water in my hands. Now definitely that water taken in my hand has a definite volume, but what about its shape? It will have the shape of my hand. If I pour this water into a bottle, there will be no change in the volume, but the shape will be the shape of that bottle. Now, so we can classify any matter that has definite volume but not definite shape as liquid. Now gas, consider in a closed room, I have sprayed some perfume from one corner of the room. Obviously, after some time, the fragrance of that perfume will be spread in that entire closed room, because it is possible for that gas particles from the spray to move around. So, matter which does not have a definite shape and a definite volume can be classified as gas. They occupy the shape as well as the volume of the container in which they are kept. Let me show you another example to make you more aware about gases. Here consider I have taken a closed glass tumbler, and in one portion I have collected some smoke from an incense stick. Now the smoke is obviously gas, you know that, and the gas enclosed in this glass tumbler have the shape as well as volume of this tumbler. Now I place that tumbler on the top of a second tumbler. Now it is possible for the gas particle to move around, and obviously now the gas particle will have a shape and size of that combined two tumblers. That means gases does not have a definite shape and a definite volume. They occupy or they take the shape as well as volume of the container in which they are kept. Now, let me show you a pictorial representation of how the constituent particles are arranged in these three physical states. In the case of solids, as you can see, the constituent particles are very tightly packed. That means the interparticle attraction between them is very high and the spacing, interparticle spacing is very less. As a result of this strong interparticle attraction, it is not possible for these particles to move from one place to another. The only thing that they can do is just to vibrate from their own position. Now, suppose I am passing certain amount of thermal energy or heat energy into this solid. That means consider ice cube as an example of a solid. You know that when we heat this ice cube, it is obviously it will melt. It is because when we apply heat energy or thermal energy to an ice cube or a solid, the vibration that these interparticles are showing, it will become tremendous. They will start vigorously vibrating. As a result, the interparticle attraction between the particle weaken and they move away from each other, which leads to the transformation of solid to liquid. So the minimum temperature at which solids changes or solids transform to liquids is known as the melting point of that particular solid. In the case of liquids, as you can see, the constituent particles are not that tightly packed. When compared to solids, they have some freedom of movement, but still the interparticle force of attraction is weak. So these particles, it is possible for them to have a slight movement. Again, as in the case of solid, if I'm supplying certain amount of thermal energy or heat energy to these liquids, it is possible for them to move and vibrate vigorously around the container, and that leads to the transformation of liquids to gases, and the temperature at which the liquids get transformed into gases is known as the boiling point, and the process in which the liquids getting converted to gases are known as evaporation. So when you analyze the representation of gases, as you can see, the interparticle force of attraction is very less in the case of gases. It is very easy for the gas particles to move wherever they want, and that is the reason why they take the shape and volume of the container in which they are kept. Also, now you have to be aware with the term fluids. From the name itself, you can understand that anything that can flow is known as fluids. When you analyze liquids and gases, as the interparticle force of attraction between them is weak, it is possible for them to flow as well as move. And that is why both liquids and gases are taking the shape of the container in which they are kept. So, liquids and gases together we call them as fluids.